All right, welcome back. Why don't you use what we learned about yesterday with our first legal move and see if you can solve this equation for x. Remember, you can also use other strategies that maybe you've started to develop along the way, and then we'll talk about those. So here, we're going to have a triangle, a 3, and 2 more triangles, balanced with a triangle and 9. We know from our last lesson that because there are triangles on both sides, I can at least remove one triangle from both sides. So now I have a 3 with 2 triangles and a 9. So what would I have to add to 3 twice to get to 9? Well, our triangle is going to equal 3. So if I do 3 plus 3 plus 2 times 3, that has to be the same as 3 plus 9. So 3 plus 3 is 6. 6. This equals 12. So our check works. So x is equal to 3. Based on what we've been doing, we are going to investigate a new legal move today. So if we look at this, 2x plus 4 equals 10. We know that we can represent that with 2 triangles and a 4 balanced with a 10 on the other side. Now we know that we can remove equivalent values from both sides. So up to this point, we've been removing triangles. We can actually start to apply that even with our blocks. If we think about it this way, that 10 really is the same thing as 4 and 6, right? Because 4 plus 6 together would also be 10. So we're replacing the 10 with 2 equivalent values. And then once we do that, because now we have 4 on both sides, we could remove that, leaving us with 2 triangles on the left and a 6 on the right. So our triangle is going to equal 3. Or in our check, 2 times 3 plus 4 has to be the same as 10. 6 plus 4, 10 equals 10. So x is equal to 3. And what we just did here is basically look at our second legal move for hands-on equations. So I can remove the same number value from both sides of an equation, which is the balance, and the equation will remain balanced because we're removing equivalent weights. And we can show this strategy by crossing out the value we want to remove on both sides and write what is left over the value, like we see here. So I did it by breaking this into the 2 numbers to show you, but essentially what we're doing is we're taking away 4 from the left, so we're going to take away 4 from that 10, leaving us with 6. If it helps you to break that piece into the equivalent value from the other side, you can definitely do that as well. A lot of it just depends on what you feel comfortable with. So let's just review our legal moves so far. So legal move number 1 is the one we did yesterday. We can remove the same amount of shaded triangles or unknowns from both sides of the scale, and we can remove the same number value from both sides of the scale. Just remember that removing triangles or numerical values does not change the equation. The scale remains balanced and our problem becomes simpler. And that's really why we do it. By removing some of the items, we don't have all that extra stuff to look at, and we can focus on just those essential pieces. So let's go through a few examples. So we actually did this one already, so we're going to go ahead and skip that example. We're going to go to example number 2. So in example number 2, we have a block of 20, a block of 4, is balanced with 4 triangles plus 2 more triangles and 6. So with the 6, what I'm going to do here is I'm going to regroup that 20 into 18 and 2, because now my 6 can be replaced by that 2 and 4. So I'm going to remove those from both sides. And to make it simpler, now I just have the 18 on the left and then our 6 triangles on the right. So if 18 is split between 6 triangles, then 3 is equal to our triangle. So our check, 20 plus 4, is the same as 4 times 3 plus 2 times 3 plus 6. So 24 is equal to 12 plus 6, 6. That checks, so x is equal to 3. I want you to pause the video and work through the next 2 problems, and then when you're ready, go ahead and restart the video and see how you did. All right, on this one, because we have triangles on both sides, I'm going to go ahead and start by removing 2 triangles from each side. And I'm going to replace my 13 with a 5 and an 8, which makes me able to remove my 5. So now I have 2 triangles balanced with 8. So my triangle is equal to 4. So 4 times 4 plus 5 has to be the same as 2 times 4 plus 13. 16 plus 5 is 21. 8 plus 13 is also 21. So our check works. So x is equal to 4, for example number 3. So 5 triangles and a 3 on one side, 2 triangles, 18 on the other. Legal move number 1 allows me to remove 2 triangles. If it's easier for you, you can also bring your work down from each step to help show that. So now I'm going to replace my 18 with a 3 and a 15, allowing me to remove 3 from both sides. So now I have 3 triangles balanced with 15. Sorry, that's a little sloppy. So our triangle is equal to 5. So we have 5 times 5 plus 3 is equal to 2 times 5 plus 18. 25 plus 3 is 28. 10 plus 18 is also 28, so it checks out. So our triangle is equal to 5. So remember, at this point now we can remove triangles from both sides because they're the same weight, and we can also remove equivalent values or numbers from both sides of our equations.